this question, a balloon is filled with diatomic oxygen, O2, gas, at STP, that's standard temperature and pressure. We're going to be figuring out the molar mass of our gas, the molar volume of our gas, and therefore the density of our gas. Finally trying to figure out, will the balloon float or sink in air? So our first step is going to be finding the molar mass. So let's go to our periodic table and let's find oxygen. Here it is. So the atomic mass of oxygen from our periodic table is 16.00 grams per mole. However, we're talking about diatomic oxygen gas, that's O2. So we've got two oxygens. So it's actually going to be 2 times 16, which is 32.00 grams per mole. So that's going to be our molar mass for oxygen. So we can fill that in here. We had 32.00 grams per mole of oxygen, O2. So that means 1 mole of gas has a mass of 32 grams. Okay, next step. What is the molar volume of the gas in the balloon? So at standard temperature and pressure, what is the volume of 1 mole of gas? Let's head to our reference sheet. And we're looking for STP down here, standard temperature and pressure, which is 273 Kelvin and 1 atm. Under those conditions, 1 mole of an ideal gas has a volume of 22.4 litres. So 1 mole of an ideal gas has a volume of 22.4 litres. That is true at STP only. So since this question is at STP, it doesn't matter what type of gas we have, 1 mole of it is going to have a volume of 22.4 litres. So we can fill that in here. Our molar volume is 22.4 litres. Oh, that should be litres per mole, actually. So 1 mole of our gas has a mass of 32 grams and a volume of 22.4 litres. So we can now find the density of the gas in the balloon. We're now on the density tab on the reference sheet, and here's our equation for density. Density equals mass over volume. So density equals mass over volume. And here we have a mass and a volume for the same amount, 1 mole of the gas. So our mass was 32 grams per mole. Our volume was 22.4 litres per mole. So if we put that into our calculator, that's going to get us out a density of 1.43 grams per litre. So we can fill that in our answer box. 1.43 grams per litre. So we found the density of the gas in the balloon using the molar mass and the molar volume. Finally, we need to compare this density with the density of air. Air has a density of 1.29 grams per litre at STP. We're asked, will the balloon float or sink in air? So if our density is greater than the density of air, it's more dense and so it's going to sink. If our density is less than the density of air, it's less dense and it's going to float. So here we have 1.43 grams per litre for oxygen, and we have 1.29 grams per litre for air. And 1.43 is greater than 1.29. So oxygen is more dense than air and the balloon is going to sink. So the questions in this skill are just like the previous questions that you might have practiced on density of gases. However, we're using this shortcut for the molar volume at STP, which is 1 mole equals 22.4 litres, and the molar mass, and dividing those directly to find the density.